Hello, I am M.Berat GÜNER. I am a senior student at Department of Electrical and Electronics Engineering. Here is my graduation project, Design of Attitude and Heading Reference System. What is an Ahrs? With the beginning of the history, locating and orientation become very important for human generation. People invented and discovered many things such as map, compass, etc. And one of the invention is Attitude and Heading Reference System. At World War II, HRs are developed for navigating rockets. Direction of the vehicle is the basic information for navigation because position depends on the movement direction of the vehicle. After that, its usage area spread out to marine, aerospace, land systems, smart cell phones, and virtual reality glasses, etc. An attitude and heading reference system consists of sensors on the three axes that provide attitude information including roll, pitch, and yaw. How HRs work? It contains an IMU, an ADS and microcontroller unit that reading sensor values at three axes and embeds the sensor fusion algorithm. Since system using MEMS-based IMU, it gives noise information. So the system should eliminate this noisy information with fusion algorithms and calculate Euler angles. In old days, they were using gimbals. They were heavy and large structures, so they are not useful as MEMS-based IMU. I have used M.Berat as IMU and Arduino Uno and Medvix filter as sensor fusion algorithm. MCU unit runs all calculations and fusion algorithms and gives Euler angles as final. I choose these components because they are economical, accessible, and impressive in terms of performance. Also, I have used Medvix filter because it has very close performance to extended Kalman filter, but it don't require too much calculations as AKF. Medvix filters working principle. At step 1, we are obtaining sensor measurements. At step 2, orientation increments from accelerometer, magnetometer, and gyroscope. At step 3, fusion measurements. And Medvix repeats steps 1 to 3 for every time instant. Here, at the right of the slide, we are seeing a block diagram of Medvix filter. Simple MATLAB demonstration. I tried a simple version of HRs in MATLAB and found that I got a decent data from IMU and after a very simple filtering processing, but this is not an exact Medvix filter, I got a basic level of HRs system. Hello, you are now seeing my attitude heading and reference system demonstration. This is my microcontroller unit and this is my IMU. In here, I have run a simple attitude heading and reference system code in MATLAB. This is not all of it, but here it shows lots of information to us. I have already calibrated my magnetometer, and this is my magnetometer calibration matrix. Blue ones is soft iron distortions, and red ones is hard iron distortions. So now let's demonstrate main code. Now you see at orientation viewer, when I rotate my IMU, my system, orientation viewer is changing. Now Z direction shows downward in here and also in orientation viewer, Z direction shows downward. Now here I am changing Z direction. Now you see that. So this is a simple attitude heading and reference systems. Finally, using the Arduino IDE, I read the data from the sensor and applied Medvix filter. At the end of this, I got the roll, pitch, and yaw angles. After a few calibrations, I will show this on the screen at the top of the system. I need calibrations because accelerometer fusing and magnetometer calibrating is not very perfect at this system. Thanks for listening.